So there are various problems that you can get when you're taking part in these online data science problems. So I'm going to focus on mainly the most common ones, classification and regression. So for classification, you're building a model that's going to classify whether your data set belongs to the blue dots or the orange dots. So the model that you see visualized here with a nice soft decision boundary there, it's a neural network that separated the dots according to their colors. So the top triangle is for blue dots, the bottom triangle is for orange dots. So now you also need to be aware of what the competition uses to score you, like what kind of metric they use. Most commonly, they would use an accuracy. I've taken part in challenges where they also used AUC. So here you're optimizing to get a score as close to 1 as possible. So 60% for accuracy would mean your model is 60% accurate. If it's less than 50%, it means that your model is worse off than just random guessing. So you can just flip a coin and decide which one of the classes that model belongs to. You're going to perform way better than that particular model that was built. And the type of data you would get for this kind of challenge, it's everyone that I visualized in the previous slide. So your text data, tabular data, images, and sound. So now the next problem that you're going to find is regression. So here you're not predicting a class, but you're predicting a continuous variable, right? So you're trying to model the relationship between inputs and output. For example, your input could be the weight of a car, and then the output could be fuel consumption. So the model then would say, for this weight, I predict that it's going to consume this amount of fuel. So the score that the metric that they normally use on these competitions, it's MSC. Sometimes they also use root mean square. So root mean square is just the square root of MSC. So that's how we get those metrics from Python. And the type of data, text data and tabular data. So tabular data goes without saying, but with text data, I've taken part in a challenge where you had to predict the retweet of a tweet. So it's text data, and then the target variable is the number of retweets the tweet got. So now you're just predicting for the next tweet how many retweets it's going to get. So you're basically predicting interaction for particular tweets.